But you need to realize that there is a circuit within here. Of course, this is copper rod, so it conducts electricity. And you can see the wire and voltmeter here. But how can it make a circuit? How can it make a circuit?
I don't get where the direction is going because there's no battery in it. So.
There's no battery. This is technically a generator. Two. Well, this rod apparently must go roll down, right, along the rail. And one thing that you may not realize, or is hard for you to imagine, normally is the rail itself is made of metal, so it can, copper actually, so it can also conduct electricity. So the circuit actually is completed whenever it's moving down, as long as they are touching the rail. Makes sense, right? This is the complete loop. That's the basic, that's the requirement in order to make something have current to flow. So in this case, it said there is a strong magnetic field going downward vertically. And he asks firstly why the voltmeter show you a deflection. So what can you say about?
The copper rod will cut the magnetic field.
Yeah, very good. The copper rod cuts magnetic field. What else? What else can you say?
Affecting the voltage.
Sorry?
Affecting the voltage.
Affecting the voltage.
Like increasing the voltage.
Right, maybe you can say according to what?
Do you mind explaining the cutting magnet?
Oh, okay. Well, maybe let me write down first. According to what? According to what? Faraday's law. Very good. Faraday said, not he said, but he find out with evidence that whenever you cut the B field, you will what? Induce, very good word. Induce EMF. Actually, you induce EMF first. And since now the circuit is completed, you always induce an EMF no matter the circuit is completed or not. But if the circuit is completed, then you also induce current. And that means a deflection. Actually, this is a voltmeter, so if you do not say about the last sentence, fine. If you only say induce EMF, that's good enough. And that causes the deflection. Back to your question, is what?
How does it cut?
Oh, how does it cut? So if I use this ruler, this is a ruler where it represents the rail, right? So the rod roll, oops, you can't roll, but you can imagine, maybe I got the other one. Right? It can roll, of course, right? Along this. And how does a B feel in this situation? It goes down like this. It points downward, vertically, like this. So while you are, I try to hold. Let's say the red one is a B field pointing downward, and while this is the actual rod that roll downward, you have to cut it.
So the rod is like this, but then it's magnetic field.
Yeah, magnetic field is going down. It's not magnetic, but
I thought the magnetic field cut like one magnetic field cuts another.
no. If you are saying one magnetic field trying to intercept the other magnetic field, that gives you the force. That's something to do with motor. Right? If you recall, the catapult effect, remember? I think what you said is something to do with this. Right? The B field of the wire and the B field from the permanent magnet, that gives you the force. Actually, there's a name called Lorentz force. But don't worry, you won't be asked about this in IGCSE. The name itself, but you should understand there's a force, right? When two B fields try to intersect each other. But now what we talk about is whenever you cut the B field, you have
physically cut the B.
yeah, you just simply cut the B field, nothing else. But as long as these are electrically conductive, then you can have the current. But if you use a rock is not conductive.
Like if I charge up the rock.
How do you charge up a rock?
So anything that carries conducts electricity and you pass it. Yeah. Because things that are electrically conductive, they have free electron. You learn in chemistry probably. Free electron. So those free electrons actually, this is going a bit deeper into physics where the electron will spin and how the things inside the material work. But the basic idea is they are free electron. So when they are moving across, cutting the B field, they will have EMF. Could you all imagine the situation? B field go down, so you must cut it. Now, part B. State what happens if you increase the strength of the magnetic field. So diffraction stronger or more in the same direction, of course. Reason is what? What should you write about the reason? Yeah, the rates of cutting B field increase. Or you can also say, I would suggest increasing the strength, meaning that the density of the field line
so because higher density, so the rate increases.
Yeah. What happened to the density though? When you increase, when you so-called increasing the field strength, the density is also increased. More lines. Does it make sense to you? Let's say normally only per 1 cm distance you have the next B field line. Now you get to even shorter, 0.5, 0.1, more dense. So you cut faster, cut more in the same time. So that means cut faster. The rod itself roll with the same speed, but since you've got more B field line, you can cut, so you cut faster. Right? Okay, number two. Number two, you need some imagination. Is that slightly increase the slope of the copper rail? So let's say originally like this, and now it go even steeper. And what does that mean? You cut even faster, right? So deflection, you would say it also increase, and the reason is again the copper rod. I think we should say this first. Copper rod rolls down faster, and that is to say, again, cutting B field faster. There's a tricky thing that if you think deeper, you figure out there's a trick in this question. Not trick, but they are being very careful about their wordings. Last year there was a student asking me why does it need to be slightly but not a lot?
Because if it's too much of the curve.
Yeah, and what's the problem if, let's make it extreme vertical, and what will happen? Direction is same as in what? You mean? Very good. The way the rod is moving is the same as B field, so you can't cut any B field. And that's why they only say slightly, so that you only roll a little bit faster, but you're still cutting the B field. Actually, there should be some, you can do an experiment and figure it out. It could be a very good like EE topic. That figure out what degree will be the best. Because going faster, but at the same time, when you change the angle, you're not going to cut as much. Lastly, changing the direction of the magnetic field so it parallel to the copper rail and directed down the slope. Can you imagine the last one? This is the rail, and how is the B field? Originally pointing down, now point where? Along the rail like this. So if you point along the rail like this, and you have the copper rod rolling down, you can't cut anything. You cannot cut the B field along that. So in terms of deflection, what do you write?
Wait, change in that one. Wait, so right now the magnetic field is like that, right? Same as
Previous was down like this. Now it said change it to go along the rail like this. So when you roll down, you cannot cut anything. So what do you write about the deflection?
No deflection.
No deflection. Yeah, or you may write 0. And the reason is no B field being cut. Oops, sorry.